Good day, my name is Michael Rooks. Today we're going to look at some of the aerodynamics associated with a stalled aircraft. This presentation is in part based on information from a lecture by an old aerobatic pilot, Tim Brill. Many of you know that as the angle of attack on an aircraft wing approaches 16 to 18 degrees, the controls of the plane will become sluggish. If this critical angle is exceeded, the wing will stall with a loss of altitude and loss of control. We are taught not to try to control the aircraft with the ailerons. A stall can result in a spin and uncontrolled encounter with terrain. Most new pilots are endowed with an instinctive fear of stalls. Understanding the characteristics of a stall and how it affects the ailerons can make a stall less frightening and easier to negotiate. An airfoil deflects the relative wind through its geometry and angle of attack. This results in a pressure differential. The pressure differential is what gives us lift. In normal flight, increased pressure occurs at the leading edge and under the wing. Lowered pressure occurs above the wing. These pressure differentials meet at the trailing edge, resulting in turbulence. Angle of attack is the angle the chord of a wing makes with the relative wind. The relative wind is dependent on the angle of the wind that results from the combination of lift, forward velocity, and inherent wind direction and speed. The ailerons of an aircraft result in differential lift forces on each wing, leading to a bank or roll in the aircraft. Upward deflections of the ailerons will reduce angle of attack and reduce lift. A downward deflection will increase angle of attack and increase lift. A graph of lift versus angle of attack is useful in understanding these relationships. Angle of attack is plotted along the x-axis horizontally at the bottom of the chart. Lift is plotted vertically along the y-axis. Lift increases with angle of attack up to approximately 16 to 18 degrees, depending on the aircraft. After the critical angle, there is an abrupt loss of lift. As you approach the critical angle, the air flowing over the top of the wing will start to separate from the wing with increasing turbulence and loss of lift. An abrupt loss of altitude will ensue and continue until the angle of attack is reduced. Control issues can result in a spin, further complicating the issue. Turning the yoke or stick to the right will angle the aileron upwards, decreasing the lift on the right wing. Simultaneously, the aileron on the left wing is lowered, increasing the lift on the left wing. This will lead to a right bank. As the angle of attack approaches the critical angle, the same control inputs into the ailerons will produce much less difference in lift and a smaller bank. This results in a sluggish response from the controls. At the critical angle of attack, the left wing is in the back of the curve and losing lift with increasing aileron input. The lift between the two wings is near equal. Control inputs on the ailerons produce no predictable banking. As the aircraft stalls and moves to the back of the curve, both ailerons are on the back of the curve. Control inputs on the ailerons will produce the opposite effect of normal. Right pressure will result in increased left aileron downward positioning and increased angle of attack on the left wing and opposite effects on the right wing. On this side of the curve, increasing angle of attack produces decreasing lift. Right aileron control inputs will result in a left bank. With changes in velocity and nose position associated with a stall, aileron control becomes sluggish and unpredictable. Attempting to control the aircraft with aileron controls can quickly lead to a spin. In a stall, although altitude control is lost, forward momentum is maintained. Rudder control remains effective and predictable. Turn and bank control should be limited to the rudders. Understanding the reasoning behind the admonition against aileron use in a stall can help fight the instinctive use of aileron to control banking in a stall. Congratulations if you have made it to this point. Thank you for your time and thank you for your attention.